Okay, here we go. I'm just going to take you through here quadratic representations. I'm going to start with level 3. You've been working through levels 1 already and 2. In here, you had to learn about vertices. You had to learn about maximums, minimums, y-intercepts, right? X-intercepts, the way they open, and the axis of symmetry. In this level, you're doing the same thing. Now you see that we're using different language, a little more formal that says concave up or down, right? Which is really just direction of opening is another way that they sometimes call it concave up or concave down. But basically, each one of these can be analyzed. All you have to do is learn how to put them in. I will tell you, if you see a function, this is function notation here, it is saying function h, the value of function h depends on the input t. But when I go to my calculator to graph, and my calculator up here, right, it doesn't give me an option for a function called h with an input of t. So I have to just leave it called function f with an input of x. And what that means is when I put this in, I've got to use x for t. So I would do 3 instead of t minus 7, x minus 7, right? And then I can square that, make a square out of that, right? And then minus 1. So I go out here and I square it and then do minus 1, right? So when I get this graph now, I can work on figuring out all the answers to my questions. Where is the vertex? Where's the max and the min? Where's the y-intercept? Where's the x-intercept? Is it concave up or down? What is the axis of symmetry? So just so that you know, you may have to zoom, do a lot of zooming with these, right? If I want to find the y-axis, I'm going to have to go this direction. I'm going to have to stay here on this side of my screen. Let me show you something, actually. Let me do this in here. I'm going to take this screenshot here real quick. Watch this. We're going to go, I think I can do this and grab this real quick because I'm going to draw on this on my whiteboard here, okay? And here's what I want you to see. When we use this, I'm grabbing my pen out here at the same time. Sorry about that. When we use our calculators, we can't always see the entire graph, right? This thing is going up here. Let me get a big bright color here, right? So this thing is going to continue going up like this, right? For who knows how long. And at some point, if I keep going, it and the y-axis are going to meet eventually, but it might be a long, long time. I can't see it, so how do I know where it is? Well, we have to change the size of this window. We have to change this viewing window. And what you want to remember is that this is the x-axis, right? So if I want to increase this direction, then what I need to do is I need to take and look at something called the x-max, right? Right now, my x-max is set to about 17, right? And this direction is my x-min. And I can see that my x-min is about, it's about 3, somewhere real close to 3, because that's negative 3, because that's negative 2.83. If I want to go this direction, let me change colors here. Let's go with this color. If I want to go this direction, that's my y-axis. So I need to change my y-max so I can go up the graph further. Right now, it's only here at 9.43. So I need to go way up from there. I want that to become much bigger. And down here, it's going to about negative 4, right? Negative 3.9 says. So I'm not interested in going any lower. This would be my y-min. So I'm just going to leave that the same. So I'm going to say stay the same, right? But I need to change my y-max here. So let me get the highlighter here. And actually, let me change this again. Let me get this highlighter here. Let's see. No, I get another color. Sorry. So this right here, this is what I need to change, my y maximum. And I know that right now, it's not even close when I look, it's not even close to the y-axis. It's going so steep up here. I need to go way up there. So I'm going to make it huge right now. It's only going up to 9.43. It's only going about 10 now. And I'm going to change that y maximum. I'm going to change it to, I'm going to make it 1,000. That's probably going to be way too big, but I'm going to make it that anyway. And this over here, I don't care about this, so I'll leave this at -3, right? And I don't care about that. I'm going to have to be about the same size probably, but I'm not that interested in anything over here. In fact, so I'll probably, if this is 17, I'll probably just cut my screen off here. So my X max, I'm going to change that to about 12, right? Because I'm not interested in anything going this direction, right? But I am interested in getting in that direction. So now this is my changes I'm going to make. And notice I have to think about this and plan it a little bit so I can see. I want my y maximum, I want it to go up, so I'm going to go y max about 1,000. That might be too high. When I make it, I'll see. Then my y min, I want to keep the same at about -4. That might be too low. We'll know in a bit. And my x min at -3, that looks fine. And my x max, I'll just move it to 12. That's way enough. That's plenty. All right, now let's just see what happens. When I go to my calculator, now that I've kind of got this plan, I'm going to move this up. I go into menu, and I use my window zoom, and I go to my window settings. Now, let me just show you that again. Menu, window zoom. A lot of kids just go over here and they hit zoom out, zoom out, zoom out, zoom out. And it might take them forever. And when it zooms out funny, and you can't customize it. But what I'm going to do is I'm going to customize it. I'm going to say my X min, I was going to keep the same. My X max, I was going to set that to 12, right? My Y min, I was going to keep about the same. But my Y max, I was going to try and make that like 1,000, right? And this here where it says the scale, this auto scale, I'm going to leave the scale the same. Whoa, I didn't definitely need, this is 1,000. I didn't even need to go to 500. In fact, this is half at 500, and half of that would be 250. So I bet I could get there if I even just put like 180 in here. 180 might be good. Let me fix this. I don't want to go to 1,000. So again, menu, window zoom, window settings. 1,000's too high. Let me try 180. Yeah, that's pretty good. So I can see where it goes down and hits the x-axis, and I can see where it's going to hit the y-axis. And guess what I'm going to do? I'm going to be able to now do a graph trace. All right? And I can see that it's got the point right here. It's underneath there. As I scroll, I can get up here and see my y-intercept. There's my y-intercept. Did you notice it came up when I touched it? Y-intercept. And down here is the value. When it hit the y-axis, the value was listed here. By the way, if I trace, let me show you that again. Here we go. I'm going to move the label up here. And if I trace, I'm going to move everything over so I can see this a little better. I like that better right there. Okay, so menu, trace, graph trace. And if I trace, I can use this, right? Tool. When I get down here close, it'll give me my zeros, right? And it'll give me my minimum. Okay. There's my minimum, right? Right there. And it gives me my other zero. I've got another zero there. Okay, hit that number. And then as I zoom, well, I don't need anything else there. The only other thing I'm probably going to need here, right, is my axis of symmetry, which we learned before. You can go menu, you can go down here and analyze your graphs, and you can look at analyze your conics and find your axis of symmetry using that tool. It'll tell you. By the way, there's another way to do that, which is, of course, when you analyze the graph, when you trace the graph, right? When I traced the graph and it got me to the minimum, that vertex at the minimum, right? Notice the vertex has the same x value as the axis of symmetry, right? All the points on the axis of symmetry have an x value of 7. These all have an x value of 7. So once I saw this, I actually didn't even need to use the tool to find the axis of symmetry because I knew it was going to be all these points where x equals 7. All the points where x equals 7. That's my axis of symmetry. Okay? So anyway, level 3, going here, this is your level 3. You'll need to find all of these things. Okay? You're finding the vertex, the intercepts, the axis of symmetry, describe opening up or down, and if vertex is max or min. Level 4, it's pretty simple actually when you look here. How many roots do functions have in common? Now remember, the roots are the zeros, so how many roots are there? This may have, and what you're doing here, all right, let me show you what this means. So let me do this real quick. Take these both here and move this out of the way, get into another spot on my whiteboard here. Yeah, we see it. Go away. Okay. So I have a couple of questions here. It's asking me about the roots of these two functions. It's actually asking me about this graphed function here and this different written function there. It's asking me to compare these two. They are not the same functions. But it wants me to find out what are the roots here of this, which roots is another word for zeros, which is another word for x-intercept, right? So you're going to want to check the x-intercepts here, the zeros or whatever here, and then compare it here and see if they have any in common. This one is a different question, right? But again, one thing that we're still doing the same way is we are checking what is the maximum for this function and comparing it to the maximum for this function. So you're going to need to use your calculator. You have to graph these to find your maximums, right? Okay. Anyway, you'll see every one of these you're comparing a function in written form to a function in graph form, different functions, comparing these values, the y-intercepts, and then checking the concavity. Remember, concave up or down. This is another way of saying, does it open up or does it open down? In level 4, now we have a table form. We have a table form. And that is where I'm going to take you for a minute here. Let me go over here. See this table or this graph that we have here. We have this beautiful graph of this parabola. We know that it has symmetry, meaning this axis of symmetry means everything on the left is equidistant from that line to everything on the right, right? If I was to draw a line straight through, this point over here would be the same distance as that one. It's like it was reflected across a mirror, right? So they are symmetrical. Okay, and then this is something I told you that we would be talking about today. I mentioned it yesterday, and I told you, what does symmetry look like? Well, when it's graphed, we can see symmetry this way, right? When it's written, we know we have symmetry when we see a square. We know the square means we're going to be having a parabola, and parabolas are symmetrical. But how can I tell from looking at a table? So here's what I want to do. If I hit Control T, right? Control T right here, it opens up this split screen table, Control T. Now I want you to notice what happens as I scroll over here through my table. It's going 107, 74, 47. So you notice it's going down, but something happens. Look at this pattern. 11, 2, -1, 2, 11. Do you see symmetry in that pattern? Look at it. It's going down, 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 up, 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 up. What number do we have here at 4? 26. So what number do you think comes after 11? 26. How about now? 47 and 74. What numbers are going to be on the other side? 47, 74. So that's what symmetry looks like in a table. The outputs go and then go back up, go down and then back up. In this case, down and then back up, right? In the event of a maximum, it would go up and then back down. But the numbers before the vertex are going to be equal outputs to the numbers after the vertex. We're just going to see it in a table. So here you have In this assignment, you have to check the concavity. Look at this. What's happening to the numbers? Where is it going? It's at 20, 12, 16, 2, 0, 0, 2. And then, so do you see the symmetry? What direction would this be shaped? And then you can compare it to the concavity here. Is this opening up or opening down? That's what they want you to figure out. How about this? Look at this table, right? See the function's value. Don't forget this is the input. So the function value on this side. See the function value. Where would the function's maximum be? Now, here, these inputs are not giving me the exact line of symmetry. I don't know where the vertex is. So if I look, I don't see symmetry exactly here. I see something kind of like symmetry, but it's off a little bit. And that's because we're not using the vertex is going to be somewhere, not right exactly here, but somewhere a little bit closer on this side, just barely. But you can still figure out where the maximum would need to be. It's somewhere around here, right? Then what about this maximum, right? You can look that up. And here you have the functions, right? So now, given a story problem with the function given to you, right? You have to compare this story problem and this function to this story problem with that function and answer which one has a greater maximum, which one has a greater y, which one has a greater x intercept. That's level 5. And then level 6, you have two functions again given to you, and we're asking this question, which one reaches a maximum height? And then again, two functions, which one started at a lower height? So I'm going to let you work on those on your own, okay? But really, this if you understand this stuff, once you get through here, level 2, you should be pretty understanding. You can get through this in a day. And in fact, you can even get through this in less than a day. So I'm going to let you get working on that. But first, I'm going to show you one other video.